Today, I'll show you how I turned an ordinary mirror into a cool piece of art using my laser. Are you guys ready? Welcome to Millopine Lasers. Let's get started. To do this project, I bought a mirror from a local store, some LED strips, a mirror touch switch from Amazon, and an LED driver unit. When you buy the mirror, try to get some extra pieces of the same mirror you bought. This is extremely useful to run some trials before you engrave the actual mirror. To start off, finding the perfect design is key. You can either browse the internet for some ready-made designs that catch your eye, or if you're feeling extra creative, you can even design one from scratch. I personally love using a program like Illustrator to bring my ideas to life. Now, when it comes to designing your mirror, it's important to keep functionality in mind. You'll want to make sure your design is wide enough to provide ample light when you're using the mirror. Now, pay close attention to the thickness of the mirror you choose. It's a critical factor to consider. If the mirror is too thin, you run the risk of cracking it, especially when using high power settings. On the flip side, if the mirror is thicker than 5mm, you might encounter some issues with the touch sensor. It could struggle to recognize your touch commands, which can be quite frustrating. For this particular project, I used a mirror that was 5mm thick. It struck the perfect balance between durability and touch sensitivity, making it ideal for my project. Before engraving the actual mirror, I utilized the extra mirrors I purchased to conduct tests and determine the optimal power and speed settings. My first instinct was to use 2 passes. For removing the coating on the back, I found that using 35% power at 100mm per second worked like a charm. And for achieving that perfect white engraving, I settled on 30% power at 100mm per second. Don't be afraid to test, tweak and adjust until you find the right settings for your specific material and laser engraver. So when it comes to engraving big workpieces like this, you gotta use something called tiling. Basically, you break your design into small sections and engrave them separately. Luckily, with Lightburn, they've got this awesome feature called Print and Cut Wizard that makes it a breeze. Now, here's the deal. Not all lasers are designed to handle large workpieces. If you've got an open frame diode laser, you're golden because you can use this feature without any issues. But if you've got a CO2 laser, it needs to have the pass-through feature. I did this on my xTool P2, which has an automatic pass-through feature. It has a conveyor-like setup that lets you feed workpieces up to 3 meters long automatically. Trust me, it makes the process so much smoother and saves you from the hassle of aligning multiple sections manually. But there's like this 4-inch gap between the workpiece roller and the actual work area. And if your workpiece isn't long enough, it won't slide all the way into the work area once the edge crosses these rollers. I totally overlooked this when I bought the mirror and had to improvise. I slapped a piece of MDF at the back for support and attached an extra mirror on the end. That way, those rollers keep on pushing my workpiece. Things went well until it didn't. I hadn't set up my conveyor feeder properly and I ended up ruining my workpiece. The mirror I bought was exactly the same size as the machine's work area and had no wiggle room. Also, I wasn't running the latest version of XCS software, leading to some software errors. However, I managed to salvage what was left of the mirror. I contacted xTool and they replied within 12 hours and gave me a newer release of the software that cleared up all the issues. I made some minor design adjustments and tried engraving the smaller mirror. This time, the support I used on the back of the mirror wasn't perfect. The MDF hit the edges of the machine, which moved the workpiece, and when I ran the second pass, all hell went loose. But I had to make this work and show you how you could do it so you don't make the same mistakes I did. I stayed up at night testing and figuring out the best way to do it, and that's when I thought I had to do it in one single pass. I ran more tests and figured out that I needed to use 78% power at 125mm per second speed to remove the coating and engrave the mirror in one pass. I also broke up the design into 2 halves to save time. If I hadn't done that, the laser would have had to travel all the way between the 2 sides over the blank area without doing anything, wasting so much time in the process. If you want to learn cool tricks like these, you should definitely sign up for our free 7-day course on lasers, which is a comprehensive yet simple guide for anyone getting into laser engraving or cutting. You would also be getting cool tips and tricks on lasers every week in your email after the 7-day course. I'll leave the link in the description. Do sign up and you won't be disappointed. Also, if you haven't subscribed to the channel yet, do check it out and subscribe for some cool videos on lasers. Once I had fine-tuned design and settings, it was time to optimize the work holding setup. To do this, I grabbed an MDF board and secured everything in place with some extra masking tape. Specifically, I made sure to use tape at the point where the two mirrors met, ensuring the roller wouldn't get trapped in that gap. I then marked the corner of the design on the mirror. The xTool P2 comes with a camera that allows for precise design placement. In addition to that, those markings on the workpiece are also really helpful to achieve perfection. I fired up XCS and captured an image of my workpiece. Using those markings as reference, I positioned my design flawlessly. The P2 also has a camera-based autofocus, so you don't have to fiddle around with manual focusing. For added perfection, I used a tri-square to ensure that my mirror was perfectly square with the machine. Once all that was done, I crossed my fingers and let the machine run. After about 35 minutes, the engraving was done. Before you use any liquid to clean the mirror, make sure to wait long enough to let the mirror cool down, or else the mirror could break. I wiped the soot off and the result looked pretty good. So I repeated the same steps for the other side as well. And once that was done, I used the open plane engraving mode to engrave the designs on the corners and the small power button on the bottom center of the mirror. Breaking up the job saved me around 4 hours of time. An important tip is to always flip your design horizontally so that the design is the right way up when you engrave it. Also check if the power button design is aligned correctly before engraving. If you're using a diode laser, you need to use 2 passes, one for removing the coating and one for engraving. But before you run the engraving pass, you'll have to coat the engraving area with black paint because diode lasers do not interact directly with glass. Once the engraving was done, it was time to install lighting. The touch switch I bought could control 2 LEDs individually, so I used a warm white and a cool white strip. I used acrylic pieces to attach the LEDs and used some pine for support. You could also 3D print the support or come up with your own ideas for how you want to mount the LEDs. The cost of making an engraved mirror with lighting that's 2 feet by 3 feet is under $100 if you find the right supplies. Could this be a decent business idea? Tell me in the comments below how much you would pay for a mirror like this. If you want to watch more videos like these, please check out our channel and subscribe if you haven't already. If you found the video helpful, please leave a like and tell me what you think in the comments below. Thank you so much for watching and I look forward to seeing you in the next one.